Section 11.4. This is all about three-dimensional figures. It's very definition heavy, so let's make sure we understand the definitions. A polyhedron is a three-dimensional solid that's entirely bounded by polygons. There are no curved sides or edges. Okay, that's a big thing. If there's any curves at all, it's not a polyhedron. The faces are the sides that make up the polyhedron. So the faces are going to be polygons. They could be rectangles. They could be pentagons, whatever. The vertices are where three or more edges meet. The edges are the line segments that are formed by the intersection of the faces. And the base is what we use to name the polyhedron. So the base could be, it could be a square, it could be a triangle, whatever. Classifying solids, they're classified according to their base. So if you see classify it, that just means name it. And then the last thing, a cross section is a slice. You can think of it as a slice of the three-dimensional figure, and it's going to form a two-dimensional object. Okay? So we have different types of solids. All these on the right are not polyhedron because they all have curves. A cylinder, you can think of like a soup can. That has curved sides. That's not a polyhedron. A cone, you can think of an ice cream cone. That has curved sides, right? And then a sphere, you can think of a ball. That is not a polyhedron because it's curved. Prisms and pyramids are polyhedrons. So if we look at this prism here, a prism has two bases. So it has a base on each end. So it has a triangle on each end and then segments connecting those bases. So that's what a prism would be. It's two polygons that are connected by line segments. Where a pyramid, you have one polygon on the base, but at the other end, the segments form a point. So that is the difference between a prism and a pyramid. A prism has two bases. A pyramid has one with a point at the other end. And an interesting thing happens. There's an interesting formula that occurs in relationship to the faces, vertices, and edges of a polyhedron. The number of edges is equal to the sum of the faces and vertices minus 2. Okay? So you could count all these things, or you could figure out the faces and vertices, add them together, subtract 2, and you'll get the number of edges. So here we go. I'm going to do the first one entirely by counting, and then the second one I'm going to use this formula to show you how much time it will save us. All right, tell whether the solid is a polyhedron. If it is, name it, and then find the number of faces, vertices, and edges. So look, there are no curved sides. So first thing, is it a polyhedron? Our answer is yes. Now we need to name it. Well, it comes to a point. So it's a pyramid, but what type of pyramid? We look at the bottom of it. The bottom shape is a triangle. So this is a triangular pyramid. Okay? So again, it comes to a point. It doesn't have two bases. It only has one basis and comes to a point. That's a pyramid. Now we need to talk about the number of faces it has. You can think of it as the number of surfaces. We have the base at the bottom is 1. Then we've got 1 in the front, 1 in the back, and 1 in the side. So that's a total of 1, 2, 3. It has 4 faces. How many vertices does it have? You can think of it, how many points does it come to? 1, 2, 3, 4 vertices. And then how many edges does it have? You could either use the formula or count. 1, 2, 3, and then along the bottom, 4, 5, 6. It has 6 edges. You could have used the formula. What's 4 plus 4? 8. What's 8 minus 2? 6. So that formula works. All right. What about B? Is this a polyhedron? Are there any curves at all? No, there's no curves. So yes, it's a polyhedron. I now need to name it. So it doesn't come to a single point, so it's not a pyramid, it is a prism. But what type of prism? We look at the shape that forms the bases. This shape has 1, 2, 3, 4, 5, 6, so that is a hexagon. So we call it a hexagonal prism. And now let's do face, vertices, and edges. Faces. How many faces? Okay, here's the easy part. If it's a prism, how many sides does the figure have? 6. Well, it's got 6 faces around the side, and then it has 2 bases, so it has a total of 6, 7, 8 faces. What about vertices? How many points does it come to? Well, the vertices are all going to happen on each base. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 12 vertices. Now we can use the formula to find the number of edges rather than counting. So all we need to do is 8 plus 12 and subtract 2. So the number of edges will be 8 plus 12, 20, minus 2, has 18 edges. You can verify. You can count each edge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So either way, if you want to count it or use the formula, you should get the correct answer. Is this a polyhedron? That is a big no. Why is that not a polyhedron? Because the top is curved. That's it. So there's no naming to be done. Describe the shape formed by the intersection of a plane and a solid. So this is a cross section. So if we have a sphere and we take a cross section of it, what shape does it form? It's a circle. My handwriting is gorgeous. All right. What if I have this pyramid and I take a cross section? What shape is formed? Well, how many sides does it have? 1, 2, 3, 4, 5. What shape has 5 sides? That is a pentagon. Okay. Now, let's see. Let's talk about solids of revolution. A solid of revolution, let's define that. A solid of revolution is simply a 3D shape formed by rotating a 2D shape around an axis. Okay? What is the axis of revolution? That's just the line you rotate a 2D shape around. So if we look here, I've got this rectangle, right? Got this rectangle. But if I rotate it around this line and spin it around, it turns into a 3D shape. It turns into a cylinder. So if you take a rectangle and rotate it around this line, it forms a cylinder. So let's think about what type of solid. So sketch the solid produced by rotating the figure around the given axis, then identify and describe the solid. So I've got a circle here. Imagine I'm going to rotate that circle in 3 dimensions. So imagine that circle coming out towards you and rotating all the way around. What is that going to form? That's going to form a sphere. Guys, a lot of times in your book or something, you'll see a sphere is denoted as like a circle with a little circle. So it almost looks like an olive or something, or sometimes they'll use a little bit of shading underneath, just so you can see that it's a 3-dimensional figure. That is a sphere. Because if you don't do the little shadow, sometimes they do a little shadow on the figure, or they put a little circle or something like that, just so it looks 3-dimensional. But yes, if you spun this circle around this line, it would form a sphere. Okay? What about this triangle? Imagine flipping this triangle out towards you and rotating it up. Imagine rotating up around this in 3 dimensions. So if I'm rotating it around that, what shape is that going to form? Oh, that's going to form a cone. Okay. All right. Next couple problems. Describe the shape formed by the intersection of the plane and the solid. Well, this cross section here forms the bottom is a rectangle, so that cross section is also going to be a rectangle. This cross section, the end is a pentagon, that's going right through. That is also going to be a pentagon. Now we got to be careful because these were going like straight through them. This is kind of taking a slice out of a corner of a box. Imagine taking a weird slice out of a corner of like a tissue box. It's not hitting the bottom at all. So this has 3 sides, so that cross section is a triangle. So the thing that I wanted to point out there is a cross section isn't necessarily always going to match up with the base. Depends where you take the cross section out of. All right, more practice with telling whether a solid is a polyhedron. If it is, name it, find faces, vertices, edges. Okay. This one, yes, there's no curved sides. Yes, it's a polyhedron. Its bases are pentagons. So now we need to do the faces, vertices, and figure out the edges. So we're going to count now. Faces. It has two bases and 1, 2, 3, 4, 5 sides connecting them, so it has 7 faces. The vertices has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 vertices. And the number of edges is just these two numbers added together. 7 plus 10 is 17, minus 2, it has 15 edges. This is not a polyhedron. This is a cylinder. It's curved. It is not a polyhedron, so we don't need to do anything else there. Now this one, it comes to a point. Yes, it is a polygon, but since it comes to a point, it is going to be a pyramid. What is the base? The base is a rectangle, so that is a rectangular pyramid. And now let's figure out the faces, vertices, and edges. Faces, it has a base and then 4 sides going up to the top, so that has 5 faces. The vertices, it has 4 on the bottom, 1 up top, that's 5. And the edges will be those two added together, and then subtract 2. 5 plus 5 is 10, subtract 2 is 8. We'll talk about more formulas and properties of three-dimensional figures going forward. Again, this section was mostly just definitions about these things. We're going to find out how to find surface area of these things and volume in the next couple sections.